Hello, so in this video we're going to look at solving trig equations, but they're going to be a bit more of a step up compared to the trig equations we've seen in the last video. Now, as a strong reminder here, hopefully you are fairly comfortable with solving those sort of equations, so you need to be able to solve equations such as sin x is minus a half, or cos x is root 2 over 2, right, or something like that, or tan x is equal to 1, right? So remember, we looked at solving equations like this with trig functions to find the angle x last time. So you need to be very comfortable with being able to do that, because we're going to be a bit more of a step up in this video. Now, okay, so what we're going to look at in this video then is now solving trig equations where the angle is a bit more complicated. So we're going to now sort of solve equations such as sine of, say, x plus 90 degrees is equal to minus a half, or cos of 3x is equal to root 2 over 2, right? So the angle is a bit more complicated, right? We don't just have angle x or angle theta. We have something more going on in the function. So here we have x plus 90 and 3x, right? So not just x, but 3x. And so it's a bit more of a step up. But we're really going to do the same sort of method and the idea that we looked at in the last section. It's really the same idea of solving. The only difference is, to compensate for this, is, if you recall again, say if we were to solve sin x as a half, remember we usually solve for a range of values of x. So for example, the common one is between 0 and 360 degrees. All the solutions here. If instead we had sine of x plus 90, the input changes, right? The inputs, or the domain, is changing, right? It's not just x, you have x plus 90, meaning that our range of values for x have to be changed as well to compensate for that. The only difference really with solving in this case is we need to adjust our interval. So instead of x now, we need x plus 90, right? And so then we would have to add 90 to both ends as well. So 90 and 450, right? And so if we solve it then in the usual way, we then need to find the range of values range of values that are in this new interval here. Okay. Say for example we had cos of 3x. Say if we were to solve cos x is root 2 over 2. Again, say if we were between now minus 90 to positive 90 degrees. So then we had, say, now let's say we're solving cos of 3x is root 2 over 2. Wow, that's x between minus 90 and 90. So to compensate for now that we have 3x, we again need to match that. So instead of x, we need 3x. And so that means we need to multiply everything by 3. So minus 90 times 3 would be minus 270. And 90 times 3 is positive 270. And that is our new interval we need to find our answers in. Okay. Once we do that, once we change or adapt our interval, it's pretty much exactly the same. Okay. But yeah, so we're going to look at some examples now to put that in practice. Okay. So in this example, first of all, we need to solve the equation cos of 3 theta is 0.766 in the interval 0 to theta to 360. Right. Now again, I did emphasize last video, you need to pay attention to the interval. This video is going to be even more important that you pay attention to this. I'd make a note of it like I've done here. Right. So what I'm going to do then, well, I'm going to do what I've just highlighted, right? we're going to match our interval or the theta to what we've got actually, right? So we don't have theta, we have 3 theta. So we need to reflect our interval for 3 to make it 3 theta, not just theta. Well, how are we going to do that? Well, we multiply by 3, right? To every part of the inequality. So 0 times 3 is 0. Theta times 3 be 3 theta, which is great because now it matches what we've got. And then 360 times 3 would be 1080 there, right? And that is our new interval, right? So if I highlight it, if I rewrite it, it's going to be between 0, 3 theta, 1080 degrees. That is where we need to find our solutions to be here, okay? Now then, we're going to solve in the usual way then. So we can sort of sketch the cosine graph to help us spot where the solutions would be. So again, we only need to consider 360 really. Because once we find 2 solutions, remember we can find others by adding 360, right? Because it repeats itself because the graph repeats itself every 360, we only need to consider the first 360 degrees of the graph. So this is the this is the sine graph, sorry. The cosine graph would look like this. There we are, at 1 there, -1. Right, so we need that first solution. So we're going to do inverse cos of this answer of 0.766 to get our angle. And then if we do that, we get, put that in a calculator, we get 40.003 blah 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 degrees, right? So that is again one solution. Now, the other thing pay attention to, this would not be theta is equal to 40.0. No, it's not theta, it's 3 theta. Okay. So we'd have 3 theta is this first angle here. Then again, we need to find the other solutions in the same way, okay, that we looked at last time. And also to say that this graph isn't going to be on the theta, isn't going to be on the x-axis. It'd be 3 theta technically, right? Which is, but yeah. So we have our cosine graph. It'll still be 360 there. Now we know the first solution then is this 40.003. So if you mark that on our cosine graph, it'd be about there, say. So then to find the other solution, if we continue it, if we read off the graph, it'd be about there somewhere. So that'd be 3 theta there. Well, again, remember we looked at the symmetry of the graph. So in the middle, at the hump, right, it's symmetrical either way, right? The left and the right of it are the same. And so because of that symmetry in the middle there, we can say then that the gap then again between at the one end of the curve, so at 0, right, and then the first solution at 40, well that would just be 40 then, right? This 40.0, that'd be the gap or the distance between one end at 0 of the curve and 40. That then has to be the same gap between the other solution there and at the other end of the curve at 360, which should be 40 again, which means the next solution has to be 40 away from 360 then, right? So to get to there. So then then if we work that out then, so it's going to be then 360. So 3 theta would be, I'll write it here, 360 take away this 40.003. If we do that on a calculator, we get 319.996 blah 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 degrees. So that'd be 319.996 for that solution there. So we can add that on to our list of solutions down here. So the first one was this 40.0. The next one was 319.996. And then, because we now found the two solutions then, so it's two solutions next to each other. So we found the first solution at 40, then the solution next to it, after it. Then to get the other two solutions, more solutions, we just need to add 360 on to each of these solutions we have, because the graph's repeating every 360, right? So to obtain the other solutions, we need to add 360 on to our current solutions we have, right? If we do that then, well, this 40.0 add 360 would be 40 or 400, sorry, 0.003 degrees. And then we need to add 360 to the next one. So 319.996. Add 360 gets me 679.996, blah blah blah. And so when do we stop then? When do we stop listing solutions? Well, it's in this new interval here. So we have to end when we get above 1,080. So we're working in this new with this new range of values there. Okay. So this so then if we add on 360 to this, then so we add the next number, so this 400 then to get the next solution after that. Gets me 760, sorry, 0.003. And then if we add 360 to the next solution, we get 1,039.996. And then if we added 360 to this solution, then 760.003, we would get 1120.003. Well, actually, this now, it falls outside the range, doesn't it? This is above 1,080, so that's it. We stop there, right? Those are all the solutions we're interested in that fits our new range of values for 3 theta. Because remember, we have 3 theta because our angle is 3 theta, right? So 3 theta is all of these values then, right, that I've listed. Right. So those are all the values between 0 and 1,080. But this is 3 theta then. Well, to get theta then, wouldn't you just then divide it by 3? So then we just get theta then. Well, then we just need to divide all the numbers by 3. Okay, so it's a bit lengthy again. There's a lot of numbers, but we divide everything by 3. So firstly, this 40.0. We get 13.3 degrees. I'm going to give it to 1 decimal place, right? Then we divide the next number in the list. So 319.996 divided by 3 is 106.7 degrees, rounded up. Then the next number, this 400.003 divided by 3, 133.3 degrees. Then if we divide the next number here by 3, 679.996 divided by 3, I get 226.7 degrees. Then if I divide this then by 3, I get 253.3. And then lastly, if I divide this 1,039.996 divided by 3, I get 346.7 degrees to 1 decimal place, right? The question doesn't specify, so I'll just pick my own rounding, okay? You'll be fine with that. But those are my values then. So in the end, those are all the values of theta. There we are. So those are all the angles. So solutions for theta, not 3 theta, but for theta that solve this equation when we have cos of 3 lots of theta is 0.766. And that makes sense because if you look then, our original interval was for theta to be between 0 and 360. Well, there we are then. All our values are indeed between 0 and 360 for theta there. So our solution makes sense. Right, okay, so that's the whole aim, right? We sort of just adjust for the fact that our theta is a bit different. So in this case, it's 3 theta. So we sort of scaled our interval by timesing by 3, okay? And then in the end here, when we had 3 theta, we then converted back to theta, right? By then undoing that, divided by 3. That's the whole aim, right? But other than that, it should be exactly the same way of solving things. Okay, now we need to solve the equation 2 sine 2 theta is cos 2 theta. So if I write that down. And our interval is 0 and 360 again, right? So between 0 and 360. Right, okay. We can't really solve this because we need either sine 2 theta to equal some number or cos to equal some number. But I've got sine equal to cos. We can't really solve it in this way. Well, actually, that I noticed then, I can't factorise anything either, right? So that means then I should probably divide. And I can divide by cos of 2 theta, right? Because remember, you need to remember the identities again. Sine squared theta and cos squared theta is 1. And also tan theta is sine theta over cos theta. It's very, very common we will be using these identities, even in questions like this. Why am I bringing this up? Well, if I divide it by cos theta, or 2 theta, sorry. Well, 2 sine 2 theta over cos 2 theta would then equal cos 2 theta over cos 2 theta. Well, the cos 2 theta is cancelled, so I'll get 1. And then sine 2 theta over cos 2 theta. Well, isn't that then tan of 2 theta by that identity there? Right? Sine over cos will get me the tan. So that means 2 tan theta, or 2 tan of 2 theta. Remember, the angle has to be the same. So 2 theta has to be 1. But then if I divide by 2, I then get tan 2 theta is a half. And so that's what we can solve then, right? So now that's a trig equation I can solve. So there we are. So again then, if I do inverse tan of a half, I get 26.565 blah 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 degrees. Well then that's our first solution, but not for theta, for 2 theta, because that's our angle, right? So if we were to inverse tan, we would get 2 theta is this, 26.565. So then to get the other solutions, it might help to draw the tan graph, right? So then we would have 90 there, 270, and then 360 there. So our first solution is 26. That would be about there, right? This is 26.6. So then the other solution is 180 away, right? Because that's when the tan graph's repeating. So I then need to add 180 on to this first solution. So if I add 180 onto this 26, I get 206.565. Well, hang on. Then we need to find more solutions. But what interval are we working in? It's not theta anymore. We need to adjust for that because now we have 2 theta. So if we have 0 theta 360, so then we should always be adjusting our interval because now we have 2 theta. So we need to double everything. So therefore we'd have 0 between 2 theta, and then 360 times 2 would be 720 degrees. That is the interval we need to be working in. So we need to make sure all our values are less than 720. Okay. Well, if we continue this on then, remember the tan graph, it repeats every 180. The next solution would be 180 along after. So if we add 180 onto this other value, 206, right? I then get 386.565. And then if we keep adding 180, I then get 566, sorry. 0.565 degrees. Then if I add another 180 on, I get 746.565. Well, hang on, we got an issue here because that's above 720. So we can't have that solution, so that's it. So those are all my values there. Right, so those are all the values below 720, and obviously a positive as well, so it's above 0. Well, then, those are my values then, but this is 2 theta. So therefore, to get to theta, I then need to divide by 2. So then I just get theta. And then I just need to divide every number by 2. So firstly, this 26.565. Divide that by 2, I get 13.3. Again, I'm going to round that to 1 decimal place. Then this 206, right? This next number in the list. Divide that by 2 as well. I get 103.3 degrees. Then this next value, 386.565 divided by 2. I get 193.3 degrees. Then this last value, 566.565 divided by 2. I get 283.3 degrees. And that is my solutions, right, to 1 decimal place, right? Those are all my solutions for theta then, right? There we are. Cool. Okay, and then obviously note that these values are between 360, which is at the interval for theta. So again, that makes sense. But there we are. Okay, cool. Let's have a look at this question then. We need to solve the equation sine of x plus 60 is 0.3 in the interval 0 to x to 360. So again, I notice my input, my x, right, is a bit different. It's not just x, it's x plus 60. So I need to adjust my interval. So if x is between 0 and 360, so then what about x plus 60? I need to add 60 to everything, right? So then 0 add 60 would be 60. And then x plus 60. And then 360 add 60 before 20. And so that is my interval I need to consider, okay? Right, so then my method's the same then. So first I need to do inverse sine of 0.3 to get my first answer. If I do that, I get 17.457 blah 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 degrees, right? Right, so then for our angle, which is x plus 60, this will be the first solution. So then, to find the other ones, well, let's consider the sine graph, right? Where should I do it? Let's do it down here, right? Right, so a sine graph between 360. It's going to be there. So our first angle is 17.457. So that'll be about there, right? 17.5, say, right? So then the other solution would be there. And that'd be the solution for x plus 60. Now, that second solution then, again, the symmetry is midway through like the top of the curve, right? It's symmetrical either side of the hump, right? Which means then that the gap, again, hopefully you notice the gap between one end of the curve at 0 and the solution is 17.5, which is going to be the same gap between the second solution and 180 when it then goes back to 0. And that gap would be 17.5, meaning to get the second solution, we need to take away this 17.5 from 180. So that means our first solution, take that away from 180. So then I'll then get the other solution, 180 take away this 17.457, which would get me 162.542 blah 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 degrees. So overall then, our solution x plus 60 is firstly going to be 17.457 or 162 point, and that is a 2, 0.542. And then we need to find more solutions, right, to our list of answers. So then we just, and again, those are all the solutions between 360. So then to find more, we just need to add on 360 on, because then it will be repeating. So if we add 360 onto this first number, firstly, we would get 377.457 degrees. And then if we add 360 onto this next solution, we get 522.542, and then more solutions after that. But this is above 420 now, right? So that, remember, we need to pay attention to our interval. That is above 420, so that's our cutoff, right? So we can't have that. So there we are. So our solution, and actually, it also has to be above 60. So actually, this solution would be rejected as well, because that's below 60. It falls outside of our range. So these are my only two solutions then. So therefore, x plus 60 is 162.542 or 377.457 degrees, right? Okay, so that's my two solutions then that satisfy my interval, my values. But again, that's x plus 60. I want x on its own. Well, to do that then, to get x on its own, I'll just take away 60, right? So then I get xn, and then I need to take away 60 to all my angles here. So firstly, 162.542, take away 60, I get 102.542, or, and then this next solution, 377.457 minus 60, I get 317.457, and there we are then. So those are my solutions then. Okay, I could round it if I want to. Again, the question hasn't told me anything, so they're not too fussed. But there we are. So there's my two values then. Cool. There we are. Right, let's have a look at this challenge question, which again, I don't think it's too bad for a challenge question. But we are asked to solve the equation sine of 3x minus 45 degrees equals a half in the interval 0 and 180, right? So again, our first step is going to be to, because our input, our x is a bit different, we have 3x minus 45 instead of just x. Here, we need to adjust for that, so we need to copy what we've got. So instead of xn, we need 3x minus 45. Now, I would recommend, well, use BidMath, right? So let's do 3x first, because multiplication for addition. So if we times it by 3 firstly, so you'd have 0. Then 180 times 3 gets me 540. And then I minus 45 to all sides, right? So from minus 45 to 0, I get minus 45. Then 3x minus 45. And then 540 minus 45. I get 495. And there we are. So that is our interval with the actual input we've got, right? So 3x minus 45. There we are. That's what we're working with. Right, okay. There we are. Okay, so then we're going to do the normal way then. So if we firstly do inverse sine of a half, we get 30 degrees. So that means my first solution for 3x minus 45, for my angle here, that's going to be 30 degrees. Well then, to find the other solution, we can consider the sine graph again. So between 360, right, there we are. So 30 is going to be about there. So then the other solution, well again, notice the gap there, not at one end of the curve is going to be 30. So that'd be the same gap there, right? Between 30 and the second, between 180 and the next solution here. Well then, the next solution then is going to be 180 take away 30, which should be 150 then, right? So then the next solution be 150, which I'll make a note here. 180 take away 30 gets me 150. That's how I've got the solution, right? Okay, well then to get more solutions then we just need to add 360 on, because then the graph repeats 360 after that. So if we add 360 to 30, we get 390. Then if we add 360 onto 150, we get 510. Well, that's out the limit, isn't it? Because we can only go up to 495. So we can't have that. But another thing to note is we've got negative 45, not 0. So we do need to check for a negative solution. So we need to go backwards as well. And consider if we, so by subtracting 360 to all more values as well. Because remember, we're going backwards. We can go forwards by adding 360, but we can also go backwards by adding 360 on as well. So if we go backwards then, we would then get the another. So if we take away 390 then by 360, we would get 30. Okay, but we've already got 30. What about 150 take away 360? We would get minus 210. Then if we did, and that's outside the range as well, because that's more negative than minus 45. So actually there is no more negative, there's no negative solutions either. So those are my three values then, 30, 150 and 390. Wow, now I have 3x minus 45. So I need to solve for, I need to get that in just x. I need to solve for x. So firstly I can get rid of the minus 45 by adding 45 to sort of both sides, right? If I do that, well, I'll get 3x then. If I add 30 onto 45 onto 30 first, I'd get 75 degrees. And then if I add 45 onto 150, I get 195. Then if I add 45 onto my final answer, 390, I then get 435. Cool. So that's 3x then. So the lastly to get x, I then need to divide everything by 3. So then I get x then. And then 75 divided by 3 is 25. 195 divided by 3 is 65. And 435 divided by 3 is 145. And those are my values and solutions for x. Then there we are. Okay, and that again, to check your answer, that makes sense because our original interval for x was between 0 and 180, and indeed all my three solutions here are in that range. Okay, so cool. that's it then. And there we are. And right, so have a look at some exam questions then, which are a bit different to some questions we've seen. So we are told a student's attempt to solve the question, solve for minus 90 to 90 the equation 3 tan x minus 5 sine x is equal to 0. And their working is set below. And we are told to identify 2 errors or omissions made by the student, giving a brief explanation for each. Now, omission, by the way, means they've left something out that they needed to write. Okay, that they needed to write explicitly write down. Anyway, let's read out then. So we're looking for 2 errors. So we can go line by. So you got 2 possibilities. You could actually solve it, or you could, if you're confident, you can go line by line, and then see if each step makes sense. So let's have a look then. So what have they done? So we started with the equation, right? Then they said tan x is sine x over cos x. That's correct, right? That's using the identity. Tan x is sine over cos, right? We know that's true. Again, you need to remember that. So that's true, right? That's true. That step's true. Then we move on to the third step. So they got rid of the fraction. So they seem to have times everything by cos. So 3 sine x minus 5 sine x cos x equals 0. Yep, that should be right. They're multiplied by cos. And then they said 3 minus 5 cos x is 0. How? Oh, okay. How have they got from here to that step then? Right. Okay. That's alarm bells. Let me rewrite that step then. Let me copy this step down. So 3 sine x minus 5 sine x cos x is 0. Okay. So how do we solve it properly from this point? Well, remember I keep banging on about you need to try and factorise whenever you can. We actually can factorise here because a sine x is common to both terms. So if we factor a sine x out, we get sine x lots of 3 minus 5 cos x equals 0. That then gives us 2 different brackets, right? 2 factors equal to 0. So that means therefore either sine x is 0 or 3 minus 5 cos x is 0. Well, hang on, let's compare to what they've got. All they said was 3 minus 5 cos x is 0. They've not got this other equation as well. So that's my first error. So if I make a note of that then, down here, part A, I think. The first error is when they didn't factorize, right? They seem to just divide it by sine x, right? But they needed to factorize. So student did not factorize out a sine x. And instead, they divided by sine x. And so they miss out solutions. So they miss out solutions from this equation here. Okay, they probably weren't looking for something as detailed as this, but I'd just thought for the sake of learning, I'd give the full details of that error. But again, that's why I keep drilling on. You need to factorize whenever you can, because if you just jump to dividing, again here, if you just jump to dividing by sine x to get rid of it, you miss out the solution sine x because you could have just factorized it out. So always try and factorize first. If you cannot factorize anything out, then yes, divide, because then you're not missing anything out. But hopefully this question shows you do need to factorize and be careful, right? Before you just jump to dividing stuff and cancelling stuff out. Okay, Okay, so that's the first error. So there's another error though. So that's the wrong step. No, that's right, sorry. But that's the wrong step. Okay, then they said cos x is 3 over 5, so they rearranged it. Is that correct? Well, you'd have, if you rearrange this, you'd have 5 cos x is equal to 3. I'd write that here. And then they're just divided by 5 to get cos x is 3/5. So yes, you would get that then. That's correct. Then they said x is 53.1, so presumably they inverse cos. So that's the last step. So if we did that then, so if we had cos x is equal to 1, cos x is equal to 3/5, inverse cos of that, does that get me 53.1? 53.1, right? So that's correct, but are there any more solutions to this, right? Very rare that you would only get one solution here. No, let's check. It has to be between minus 90 and positive 90. Is there any more solutions? Let's consider the cos graph, right? So, if we do a cos graph then. So we're basically, by the way, we're solving cos x is 3/5 to find any solutions. So we've got the first solution of 53.1. That'd be about there. But remember, it's also the range of values was between minus 90 and positive 90. Okay. If we draw the graph a bit back, right, backwards. There we are. So minus 90 would be there. But actually, if you read off the graph, there is another solution in that interval. To find that other solution then, well, firstly, we can find that solution here, right? So we've got the first solution, 53.1. So the gap, again, between one end of the curve at 0 and 53.1 is 53.1. And that means the same gap, because it's symmetrical in the hump, right, again. So at the other end of the curve at 360, and the other solution, that gap would also be 53.1. So therefore, so x is 53.1, and the other solution will be 360 take away 53.1. That would be 306.9. But then to find this other solution, then we need to go backwards by 360, right? So if we subtract 360 from this solution, then we would get minus 53.1. And actually, that is between minus 90 and positive 90. So they missed that other solution out, right? So they should have also got minus 53.1. All they've said here is x is positive 53.1, right? So there we are. Right, so the other error then is that they've missed out the other solution. So student also missed out the solution x is minus 53.1. Again, reminder, because we're in the interval minus 90 to positive 90. This falls out the range, by the way. This 306 was outside the range, so we rejected that one. But then we got this next solution by taking away 360. And that is indeed in the interval, okay? And we needed to go back by 360 because we had a negative in that interval. So yeah, but yeah, so that's the other error, and that's it, right? So those are the two errors then. Okay, cool. Right, okay, then they said the first four positive solutions in order of size of the equation cos 5 alpha plus 40 is 3/5 is alpha 1, alpha 2, alpha 3, and alpha 4. Find to the nearest degree the value of alpha 4. Right. So basically, these are basically like the first four positive solutions to this, right? That's what that's saying. If we just rewrite that equation down here, then so cos of 5 alpha plus 40 is 3/5. Okay, so if we were, then we just need to solve it, right? That's the first thing in order to find the solutions, right? So again, we don't really have an interval. It just said the first 4 positive solutions, right? So let's work with that then, right? So then obviously proceed with solving. So inverse cos of 3/5. If we do that, then we get 53.13 blah 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 degrees. So that means my first solution for 5 alpha add 40 would be 53.13. But that, so then to get the next solution, again, we can consider the cos graph. Okay, so 53 would be about there, right? 53.1. So then the other solution, again, the same ideas that we just looked at. The gap, at one end of the curve and the solution here, that gap is 53.1. That's the same gap between the next solution and the other end of the curve at 360. That same gap is 53.1. So that means the next solution be 360, take away this 53.1. Which, if I put that in the calculator, the next solution would be 306.869 blah 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 degrees. So if I write that down here then to my list of solutions, there we are. So then to get, because now we found the first 2 solutions, then to find the other ones we just need to add 360 to them. So if we add 360 to this 53, I then get 413.13 degrees. Then if I added 360 onto this next one, this 306.869, I get 666.869 degrees. Okay, there we are. And actually, remember then, where do we stop finding solutions? Well, actually, it says the first 4 positive solutions, so the 4 positive. Well, that's what we've got, right? We've got 4 positive solutions then, right? Okay. So then so then we need to solve for alpha then. So we have 5 alpha add 40. So then firstly, we need to get rid of the 40. So then we're left with 5 alpha. And then we subtract 40 to everything. We get 13.13. Then if we subtract 340 from this, 306.869, I then get 266.869. And then if I subtract 360 to this next solution, no, 40, sorry, to this next solution, I get 373.13. Then if I subtract 40 to this last solution, 666.869, I then get 626.869, right? Now that's for 5 alpha. Then to get alpha, I then need to divide by 5. So then I get alpha. So then I need to divide everything by 5. I get, so if I divide this 13.13 firstly by 5, I get 2.6. I'm going to round it to 1 decimal place. And then this next solution then, 266.869 divided by 5. I get 53. 0.4 degrees if I round it. Then this next solution, 373.13 divided by 5, I get 74.6 degrees. Then lastly, the 626.869 divided by 5, I get 125.4 degrees if I round it. Okay, so that's the one decimal place. So those are my values then. Those are my solutions for alpha, the first 4, right? Then it says to find to the nearest degree the value of alpha 4. So they told me the first 4 positive solutions are alpha 1, 2, 3 and 4. So alpha 4 then is going to be the 4th one, right? So that's going to be to the this one here. Here, right? That's the 4th one in the list. If I box this, by the way, to make it clear, these are my solutions. There we are. The 4th one in the list is this 125.4, right? So therefore, alpha 4 is 125.4, but it said as well, by the way, to the nearest degree. That means basically like the nearest whole number, right? Which is just be 125 to the nearest degree, and that is my answer. Okay. By the way, you could have, if you're very confident, you could have spotted immediately that alpha 4 would have been the 4th solution. So you didn't need to divide you didn't need to in this case, you didn't need to subtract 40 and divide by 5 to every solution. You could have just done that to the final answer there. But I thought for just the sake of demonstrating and teaching, I did it to every solution, right? But yeah, there we are. That's the answer to that. Okay. Let's have a look at this question then. Okay, so we firstly need to show that 1 over cos theta, I'll write that down here, 1 over cos theta add tan theta is identical to cos theta over 1 minus sine theta. So we need to prove an identity. Now actually, we actually did this exact question when we did the identities in chapter 10.3. So I did do it already, so I'll do it quite quickly now. But remember, with identities, we need to work with one side of the inequality, of the identity, sorry, and then we end with the other side, right? So let's start with this side, the left side. That looks a bit more complicated, right? So firstly, I notice there's no tan theta, only sine and cos at the end. So if I start with 1 over cos theta add tan theta, do it down here, I can use the identity that tan theta is sine over cos, right? So if I do that, then I get 1 over cos theta add sine theta over cos theta. Okay, and so then I can add got a common denominator of cos, so I can add both fractions. So I get 1 add sine theta over cos theta. Okay, but I'm in a bit of a pickle, right? Because I need to end up with cos theta over 1 minus sine. I have a cos on the top, but my problem is I have a cos on the bottom, right? I can kind of sort of force my answer then. If I know I need a cos on the top, I kind of just then times this fraction, top and bottom, by cos over cos, right? Right. So if I do that then, I get cos theta, lots of 1 plus sine theta, over cos squared. Now actually, this cos squared then reminds me of this other identity. Sine squared and cos squared is 1. So I can use that, I can rearrange that to say that cos squared is just 1 minus sine squared, right? If I do that then, this is also identical to cos theta, 1 plus sine theta over 1 minus sine squared theta. Right, and again, as always, key tip I keep drilling is factorise whenever you can. I can factorise the bottom now. This is a difference of two squares, right? So 1 minus sine squared would then factorise to 1 plus sine and 1 minus sine, right? Hopefully you can see that, right? It's a difference of two squares. You can check if you expand it, that's what you get. So it's a difference of two squares. So, by the way, this is like we'll say 1 squared as well. So 1 squared minus sine squared gets me 1 plus sine, 1 minus, right? So I can factorise the bottom then to get cos theta, 1 plus sine theta, over 1 plus sine theta, 1 minus sine theta. And what do you know? I've got a common factor on top of the bottom here. Cancel that out. I then get cos theta over 1 minus sine theta. And actually, I believe that should be it. That's what we got. Yeah, the other side is cos theta over 1 minus sine. So now I've got to the other side. So then I'll prove the identity. Cool. Okay, so that's part A. Part B, the more relevant part of this question. We're given that cos 2x is not 0. Okay. It says solve between 0 and 90. This same expression, 1 over cos 2x plus tan 2x, is 3 cos of 2x. Is equal to 3 cos 2x. Okay, but again, a very common strategy. You were asked to prove an identity in the first part, and then you got that same expression in part B. Well, we can sort of substitute that in because we know 1 over cos theta and tan theta is also the same as cos over 1 minus sine. That's what we've just proven. But our angle now is not theta, it's 2x. So we sort of substitute that in then. So we can, the first part then, this 1 over cos 2x of tan 2x is now cos 2x over 1 minus sine 2x, right? So we can say that cos 2x, obviously by just replacing theta in here for 2x. So cos 2x over 1 minus sine 2x is then equal to is equal to 3 cos 2x, right? There we are. Okay, cool. So I need to solve it then between 0 and 90, right? That's what they told me. And again, hopefully you are comfortable with that, what I just did. Hopefully you're comfortable with why I replaced this 1 over cos 2x or tan 2x with cos 2x over 1 minus sine 2x. Just put theta for 2x. I basically interchanged it, okay, and put that in there because it's the same. That's what we're proving in part A. Okay, and then there we are. But so between 0 and 90, then I need to solve that equation I've got. So obviously it's a fraction, probably best thing to times across, right? If I times by 1 minus sine 2x, I get cos 2x is 1 minus sine 2x. Lots of 3 cos 2x. If I expand that out then, I get cos 2x is 3 cos 2x minus sine 2x. Minus 3, sorry. 3 sine 2x cos 2x. And there we are. Okay, hopefully quite a weird bracket that is. But again, I just multiplied 3 cos 2x firstly by 1 and then by minus sine 2x, and that's what I got. Okay. Okay, cool. Okay. Right, okay. So then I can factorise and notice, if I move everything to one side, right, I think that might make things easier. Move everything to one side, so cos 2x minus 3 cos 2x plus 3 sine 2x cos 2x equals 0. Then actually I can simplify this. Cos 2x minus 3 lots of cos 2x That's overall minus 2 lots of cos 2x, right? Just collecting like terms, right? 1 lots of cos 2x minus 3 lots of it is minus 2. Then I also have the 3 sine 2x cos x equals 0. Now what we're not going to do at this point, I notice as a cos 2x, I could cancel that out. I'm not going to divide. If I want to sort of cancel, sort of deal with it, right? I'm not gonna divide by cos 2x to both sides. I'm gonna factorize it out, okay? So if I factorize it out, I get cos 2x, which is a common term, right? Then I got minus 2, add 3 sine 2x equals 0, right? Very important you do that, okay? Do not miss that. If you divided by it, you would miss this first factor out of cos 2x. Okay, so now I've got 2 of these equal to 0, so either cos 2x equals 0, or minus 2 add 3 sine 2x equals 0. And then I can actually simplify this bit, right, this equation here. So then this will just be sine of 2x then would equal 2/3, right? If I add 2 to both sides and then divide by 3, okay? So I've got 2 equations then. I've either got cos 2x is equal to 0 or sine 2x is equal to 2/3, okay? I can solve both of them separately. So firstly, I want to solve cos 2x is equal to 0, and then I'm going to do the second one here, right? Sine 2x is 2/3. Now, the key thing to note, again, our interval is between 0 and 90 degrees. Again, the question told me up here, okay, that's our interval for x. We need to adjust for that, don't we? Because we have a 2x in our angles here, not x. So if we just double everything, we get 0 lots of 2x of 180. Okay. Okay, cool. Okay, so we've got our interval. Okay. So now we're going to look at firstly solving this one, this equation. So cos 2x is equal to 0. Now, actually, if we pay attention to the question up here, it says given that cos 2x is not equal to 0. But that's interesting then, because if we want to solve cos 2x equal to 0, well, we're told it can't be 0. So that equation can't happen then, right? So we are told, but cos 2x cannot be 0. Well, then that means there are no solutions then, because we can't solve the equation, because we're told it can't be 0. So therefore, there are no solutions here, okay? No solutions to that equation. Now, that actually makes sense. Why have they told us this? This makes sense, because actually, pay attention to the question. We are dividing by cos 2x here, right? This fraction 1 over cos 2x. If cos 2x was equal to 0, we'd basically be doing 1 divided by 0. That obviously cannot happen. You can't divide by 0. So, yeah, so that's why the question has told us it can't be 0. They've not got that out of nowhere, right? So that's where it comes from. So again, you must pay attention and read the question carefully, right? So in this case, we don't need to solve this. There are no solutions coming from this equation. Okay, but we can solve this and this other equation. So sine 2x is equal to 2/3. So then our strategy will be the same. So we will firstly do inverse sine of 2/3. That will get me 41.81 blah 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 degrees, right? So that means my first solution is going to be 2x, right? Is going to be 41.81 blah blah blah. Right, so that's the first solution. To get the next one, well, we could just consider the sine graph, right, as usual. So do 360 here, say. So the first solution is 41.81. That's going to be about there, right? Somewhere there. 41.8 degrees. Now again, because of the symmetry around like the hump of the curve, so here in the middle at the top of it, right? At either end of the curve, it's symmetrical again. So at the other end, it's 180, right? At either end, it's symmetrical. So then, with that in mind, the next solution would be there, which means then that the gap between at one end at 0 and the first solution, that gap is 41.8, right? So then the gap between the second solution and 180 at the other end of the curve will also be 41.8, which therefore means the next solution will be 41.8 away from 180. So we have to take this away from 180, right? So the other solution will be 180, take away 41.81, blah, blah, blah degrees. So our first solution. If we do that, we get 138.189, blah, blah, blah degrees, right? So if we put that here, my next solution will be 138.189 degrees. And so that's my first two solutions. Then to get more, we would have to add 360, because then it'd be repeating, right, by 360 degrees. But actually, if we were to add 360 on to these values, we would be exceeding 180, which is the maximum in our inequality here, right? So actually, these are the only two values we need here, right? That will fit in with our range of values, okay, between 0 and 180. Right, so 2x is equal to all this, so then therefore we need to get x then, right? So then to get x then, obviously divide by 2, so 2x divide by 2. If we divide this 41.81 first by 2, I get 20.9 blah 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 degrees. And then if I divide this 138.189 by 2, I get 69.1 degrees, right? If I round it to one decimal place. And so those are my solutions then. So therefore, to one decimal place, the two values of x was 20.9 and 69.1 degrees. And there we are. So that's my solution. And yes, the question did say to one decimal place. So yes, so that is my two values of x to that equation. Cool. Okay, this one's going to be very hard, very hard. This one was a recent exam question. That probably was the hardest one on the paper, maybe, by a good few people, I reckon would say. Definitely one of the hardest in this sort of chapter. So I thought I'd leave it here as sort of a challenge question. Not many marks, to be fair, but this will really, really test and go over fully this topic, right? So, we're going to leave off with this. So, we are told that given for all values of k, where -1 is between k and 1, the equation sine of nx is equal to k has exactly 6 solutions in the interval 0 to 360. First of all, deduce the value of n, sorry. Okay. Right. So, there's a bit of algebra there. There's n's and k's. It's not in the usual format we like it in, right? But we're going to basically do the same idea then, right? We're really just solving, right? It's talking about how many solutions there are. So we need to sort of solve it, right? We need to look at solving it. Now, obviously, there's an n and a k, so we can't, solve it, numerically. We don't have numbers per se. But we can do the same sort of method, right? So, what we're going to do, so obviously, first of all, we got our interval. Remember, we don't have x, we have nx, so we need to adjust for that, right? So we have 0 between x and 360. So therefore, if we multiply by n, and we would have nx between 360n degrees, right? So it's a multiple 360, right? This n, at 360n here. Okay. Well, what do we do then? So it's talking. So what would you do then? Well, obviously we would do inverse sine on the calculator. We can't do that, right? Because we don't have numbers. But how would we consider the solutions? We'd consider the sine graph, right? We're going to do that then, right? So again, between say 360 degrees. There we are. So we are told we're basically solving. We're setting this sine equal to k, right? We are also told that k is above -1 but less than 1. It's strictly less than 1. So obviously 1 is at the top here and -1 is here. So k would be somewhere here or somewhere there, right? Depending if it's negative or positive, right? So, okay. Well then, you know, between 360 degrees then, right? The first sort of 360 degrees. What if k is positive, right? What if k is between here? If we draw like a generic line then, say here, and this is k, we would have two solutions then, wouldn't we? Right? Likewise, if say k was positive, so if k is positive, that means two solutions, right? What if k is negative instead, right? What if k is on the negative part instead? What if k was, say, there, right? So k would be here, k is negative. Again, we would have two solutions between in the first 360 degrees. So actually, we also get two solutions here as well. Which means that overall, then, in 360 every 360 degrees, there are two solutions to the equation, right? As we can see here, if k is positive or negative, there are always two intersections, right, which we can see there, right? Okay, so that's the first 360 degrees, and we've seen there are always two solutions, no matter what sine k is. Okay, so there's always two solutions, but we need our solutions need to be between 360n. So we need 6 solutions then. So therefore, if two solutions are in 360 degrees and we repeat every 360 degrees, that means to get 6 solutions, 2 times 3 would equal 6 solutions. There we are then. So we need to repeat it 3 times. So repeat the graph 3 times. Right, the sine graph. Well, that means then we're basically adding 360 on 3 times, or yeah. Okay, so we need to repeat it 3 times. That means we need to well, if you think about this interval here, we needed to continue the graph on 3 times, right? Something a bit like that, right? But hopefully you notice then, if we're repeating it 3 times to get 6 solutions, because 2 solutions is 360. Think of it like this, right? 2 solutions is in 360 degrees, right? So then, therefore, 6 solutions, if I times by 3, what angles do we need to consider there then, right? Times it by 3, 360 times 3 is 1080. So there are 6 solutions then when we go to 1080 degrees. Well, hang on, that means that the upper number, right, in that interval needs to be 1080, right? That means then that 1080 has to be equal to 360n, right? Because that is the degrees we need to extend to, right? To get 6 solutions here, okay? But then we just solve for n. So therefore n is 1080 over 360, which is 3. So therefore n is 3, okay? There we are. Very tricky, that is. Very, very tricky. But yeah, hopefully you get the idea, right, of that you know, we still do the normal method, even though there's a bit more algebra involved. You know, the method being we consider the graph, right? To consider the solutions. There we are. Okay, so n is 3. So that's the first part done. Then we are told, deduce the number of solutions to the equation sine squared of nx is k squared in the interval 0 to 90. Okay, so if I write that down then, we have sine squared of nx, and actually we know n is 3. So that'd be 3x is equal to k squared between 0 and 900 degrees. Now, it didn't say to find these solutions, it just said how many solutions there are, the number of them, right? That's all we need to find. Right, so we've got this equation then, but we have sine squared, is right? So we need to square root both sides, right? So then we'd either get then that sine x then, or sine of 3x, is going to be equal to plus or minus the root of k squared. Now, k squared, if we square root it, we just get k then, right? Because the squared cancels with the square root, pretty much. So we just get k then, okay? That means we get two different equations to solve, right? So we'd either get then that sine 3x is equal to positive k, or sine 3x is equal to negative k, okay? Right, so let's proceed with doing that then. So again, if our what's it called? If our interval is between 0 and 900 for x, we need to scale that for 3x, don't we? Okay, as always, if our input's different, we need to adjust that interval. So therefore, if you times everything by 3, 0 lots of 3x, and then 900 times 3 gets me 2070. Right, okay, very big number, but remember, we just need to find the number of them, the number of solutions, okay. Right, okay, so let's start with this equation then. So sine of 3x is equal to k, okay. So again, let's consider the sine graph. Obviously, again, we can't inverse sine it, because obviously k is unknown, it's not a number. So we just have to consider the sine graph to see where the solutions are. So the sine graph, again, between 360 again, say, it's going to be here. So then, we already discussed then already that, you know, if we have 1 up here and minus 1 there, if k is positive, right, so say there are two solutions every 360 degrees, right? And likewise if it's negative, right? So two solutions every 360 degrees. So then we can sort of scale that then, because now we have 2,700. Let's consider what 2,700 divided by 360 is, right? If we do that, we get 7.5, right, okay. That's telling me then I need to do 7 cycles, right? 7 repeats of the curve, right? And then another half, right? So that's telling me that if I then times by 7, right? Then and then we'll worry about the 0.5 later. If we times by 7, we're going to get 14 solutions then, aren't we? So we're going to get 14 solutions every 360 times 7, which is 2,520 degrees. Okay, so that means then we go back to where we started at now 2000 and so if you imagine then, we're basically repeating every 360 degrees. After the 7th repeat, we get to 2,520, right? So if I draw that same sine graph, this is now 2,520, right? After the 7th repeat, right? But we have a bit left over, because remember, we need to go up to 2,700. If we subtract 2,700 by 2,520, we get, I believe, 180, right? Because then that'd be half of it, right? But there we are. So we need to do another 180 afterwards, right? To get to the maximum, the maximum degree of 2,700. So another 180 then, if we continue the shape of the graph, would be there. So we already accounted for, right, the first 5. We know there are 14 solutions up to 2,520 degrees. So we don't need that. We already seen that part of the graph. We then need to consider if there are any more solutions after that, right? So then, if k is positive, well, there's going to be 2 more then, aren't there, right? And so there we are. So if k is positive, we get 2 more solutions. And then obviously if k is negative then, well, the curve doesn't go underneath, so there'll be no more solutions, okay? So if k is negative, no more solutions. Right, okay. So overall then, we already got 14 solutions, and then we might have another 2, right? Or none at all. But we'll leave it there, because obviously then we've got to solve this other equation. Sine 3x is minus k. So again, we get pretty much very similar, right? Very, very, very similar argument. We don't need to repeat it. Again, there's going to be 14 solutions up to 2,520, right? And we've already seen then that there will be 2 more solutions. There'll be 2 more solutions after 2,520 up to 2,700 if k is positive, or if k is negative, there'll be no more, right? But the thing is, we got plus k and minus k. So what's going on then is actually, in one case, k is positive, right? Because it's equal to k. In the other case, k is negative. So actually, we've got a situation. In one case, k is positive, so we get 2 solutions extra, and if k is negative, we get no more. So what we've got then is there are going to be 14 solutions at least in either case, right? So either case, so from both cases, or from both equations, right? So from both equations, we get 2 times 12, which is, no, sorry, it was 2 times 14, sorry. 2 times 14 equals 28 solutions. We get 2 times up to 25,000 degrees, right? So then obviously we got the extra 180, right? The last 180 part of the graph. So then we would either get 2 solutions if k is positive, or no extra solution if k is negative. But as we discussed, in one case k is positive, and one case sign is negative. So actually what happens is, in one of these equations we would get 2 more solutions, and in the other equation we would get no solutions. So we just need to add 2 on them, right? And we would get an extra 2 solutions in the last 180 degrees, right? Therefore then, overall, total solutions then is 28 add 2 equals 30 degrees. 30 solutions, sorry. And there we are. That is absolutely nasty question. Nasty question. Be rest assured, exam question not normally like that. Very, very rare. There's like one hard question at maybe the end of the page, but this was it, okay? Very hard question, and actually it's not worth many marks, so it wasn't that impactful. But I thought I'd throw in there, almost like a challenge question, but very difficult question. That's definitely for the A-star students, definitely. A-star, yeah, that's an A-star question, that is. But if you're aiming for it, hopefully you can sort of make sense with what went on there. But yeah, so yeah, so hopefully, if it's put you off, try not to make it knock any confidence. It is a very hard question, but that is solving equations where the angle is a bit different, right? So hopefully it made sense. Again, the core idea then, if I get away from this question, um, the core idea is that basically if the angle is different, we need to adjust for that in our interval, right? So where was it? Here, right? So we had, in not x, we had 2x, so we needed to double our interval, and that would be what the values we need to consider, that range of values. Other than that, it's pretty much the same as what we did last time. But that's it for now. I'll see you next time.